So I'm Robin. I'm on a team at Atlassian called Engineering Services. And my focus is on-demand, specifically the kind of back-end bits of on-demand. So I work on kind of ensuring that Atlassian products work well in the software as a service environment that is on-demand. And I'm really excited about Connect because plugin developers have been building add-ons for behind the firewall for ages, and Connect is a great opportunity for people to really get stuck into on-demand and start to bring some really good stuff to our hosted customers. Now, if you're coming from a traditional plugins background, probably the biggest new thing for you in Connect world is that your add-on is now going to be...
Put this way.
Yeah, it's on. Cool. So the biggest difference for you is that your Connect add-on is now hosted, so your add-on is now software as a service. And as Dave was saying, this brings about a whole load of new dimensions to your add-on, because you have to start to think about where it's going to be hosted, how it's going to scale as your user base fluctuates, and also you've got to try and predict what the running cost is going to be, because you typically have to pay for the resources that you consume when you're building software as a service. So I'll talk about some of those things, and I'll do so using this add-on, Who's Looking. So has anyone seen this or used it before? Right, so those of you who have used it will know that conceptually it's an incredibly simple add-on. Right, it really just shows you who else is looking at the issue, the Jira issue that you're currently looking at. And it started life a number of years ago as an in-process add-on built by a colleague in his 20% time. And I really liked it because I like this kind of sense of team spirit you get when you see a whole load of people crowding onto a hot support ticket or just an issue with some funny pictures attached to it. And so I wanted to bring that same experience to our on-demand customers. And so I did so using Connect in my 20% time. And the resulting add-on has been in production for about 8 months now. And it's running with just under 20,000 active users, spread across about 1,000 hosts at the moment. So let me tell you a bit about how it works. So it's a Java application running on Play, and it's hosted on a platform as a service called Heroku. And it talks to 2 different data stores, Postgres and Redis. And just like any Connect add-on, it interacts with on-demand instances. So the idea is that a Jira admin can come along and install Who's Looking into their Jira on-demand instance. And from that point onwards, whenever an end user requests a view issue page from that Jira on-demand instance, the view issue page will be rendered with an additional iframe that refers back to Who's Looking. And in terms of how we keep track of who's looking at what, well, the implementation of that is probably about as simple as you could possibly imagine. It uses polling. So the content of the XHR, of the iframe that we send back to the end user from Who's Looking issues some XHR heartbeats back to the application. And as long as we keep receiving those heartbeats, we know that the user is viewing the issue. If they navigate away, we stop receiving the heartbeats, so they aren't looking anymore. So that's a whirlwind tour of how Who's Looking works. If you want more detail, you can go and have a look at the source. It is an open source project, so you can dig into the source on Bitbucket. So there are a couple of really interesting things that come out of this and that apply to pretty much every Connect add-on. And the first is that in this picture, there are actually many on-demand instances. And what that means is that your Connect add-on has to be aware of these multiple Jira instances or Confluence instances, even though they have completely separate user bases and completely separate data sets. Your Connect add-on has to be aware of this and, of course, not mix up the data from the different tenants. So in that sense, your Connect add-on has to be multi-tenanted. It has to be aware of multi-tenancy. And then the second thing is that, of course, there are many, many end users. So the registered user base in on-demand today is about 1.3 million users. And if you include HipChat and Bitbucket users in that, of course, the Connect add-on, if it's very successful, could end up with thousands, maybe tens, maybe hundreds of thousands of active users hitting the service. So scalability in that sense and multi-tenancy are 2 new concerns that maybe haven't been such major concerns during P2 plugin development, but suddenly become important focuses during Connect add-on development. So When I started building Who's Looking, I actually had a number of really good surprises because it turns out that there's a lot of stuff that's provided by Connect itself and by some of the surrounding tooling. And I'm not going to talk too much about this because there are a number of other talks throughout AtlasCamp that cover some of these things. But in general, things like the logic to support installation of new tenants into your add-on, that's provided by both the AC Play and the ACE frameworks. Things like tooling to ensure that your iframe, if it's sitting inside the Atlassian UI, if you want it to kind of integrate nicely and look seamlessly integrated with the rest of the UI at the Atlassian product, you can use some of the tooling that Pete mentioned, like the AUI Flatpak and the ADG, the Atlassian Design Guidelines, to achieve that. So there's a lot of good stuff there provided for you by Connect and by the surrounding tooling. Now, when you come to think of your add-on as a production-ready entity, that's when some of these questions pop up again, and you have to start to think about hosting and think about monitoring, so you know if it falls over during the weekend when you're not looking at it, how you're going to be notified of that. So let's dig into some of these areas, and let's start with hosting. And hosting is actually a really good place to start because your choice of host can end up affecting the overall architecture of your add-on, which in turn can have an impact on its scalability and its resilience characteristics. So for Who's Looking, we chose to host on Heroku, which is a platform as a service or a PaaS. Hands up if you've used a platform as a service before, not necessarily Heroku, but any of the ones out there, so quite a few of you. So what I really like about platforms as a service is that as an application developer, I can just push my application out to a PaaS, and it's up and running and available to whoever wants to consume it, and I don't have to worry about what operating system it's running on. I don't have to worry about maintaining the app server or anything like that. So that's really good. And what actually happens in practice when I push my application is that it comes up on a number of isolated processes. And in Heroku speak, those are called dynos. And then when requests come in, they get sprayed across those isolated processes. Now, this pattern of requests balanced across isolated processes is a very common one. It's a common model. It's not at all unique to Heroku. So Google App Engine, Microsoft Azure, Elastic Beanstalk, which is Amazon's platform as a service, all of them use a very similar model for a few reasons. Firstly, it enables horizontal scalability because you can add and remove these nodes as your traffic goes up and down, and consequently, you can pay more or less depending on the resources that you actually need. So that's a really good characteristic. Secondly, if one of these isolated nodes goes down, your application can continue to function because the request will continue to be processed by the other nodes. Compare that to an architecture where you have a single monolithic process here. Of course, if that goes down with an out-of-memory error or whatever, then the entire application is down and no more requests can be processed. So that's a big benefit as well. Now, all of this does come at the cost of an architectural constraint, which is that you can't store state in memory whilst processing one request that will be required by a subsequent request, because that subsequent request might be processed by a different node, which of course will have a different view of what's in memory. So for example, an early prototype of Who's Looking made this mistake and stored the information about who's looking at what in an in-memory map. And of course, that was broken after it was deployed to an environment like this. And the solution, quite simply, is to take that state and extract it into an external data store. And for Who's Looking, I chose to use Redis, which is quite a nice, low latency, pretty simple data store with some nice features. Now, Heroku itself doesn't provide a Redis platform as a service directly, but like any good PaaS, it does integrate very nicely with a whole bunch of third-party services. So I can very easily just go and pick one of these third-party services, and pretty much at the click of a button, my application gets some configuration information that it needs to go and connect out to another company providing another platform service for me. And there's a whole bunch of these. There's a whole range of different services in all sorts of categories, ranging from obviously data stores to analytics to messaging, queuing. You name it, there's a service for it. So any good PaaS will enable you to access these services provided by other companies. And so I actually find it quite inspirational sometimes just to have a quick look through what's available. And sometimes I see services that just give me ideas about features. So there's you probably can't read that, but there's a time series database there. I've never used one of those. There's probably some cool stuff we could do with Connect and a time series database. I don't know. So third-party services are good. Aside from third-party services and the enforcement of kind of statelessness in your architecture, another thing I really like about passes is that they typically have a very low barrier to entry. And by that, I mean a couple of different things. Firstly, deployment is generally very simple. And in the case of Heroku, it's famously just a git push. And once you push your application, the platform takes care of things like seamless upgrades so that there's no perceived downtime by the consumers of your application. And secondly, most passes provide a free or a very low-cost tier. So you can spin up instances of your application that consume relatively few resources at little or no cost. And so as a consequence of this, I think there's probably about 7 or 8 Who's Lookings out there actually up and running. But we only pay for one of those, which is the production one, because that's the only one that needs more resources than what's available through the free tiers. And the others are used for various stages of testing, load testing, that kind of thing. So, talking about testing. So, while you're thinking about hosting and designing for horizontal scalability and that kind of thing, another area you want to be considering is testing at the same time. So, a lot of what you've learned through testing with P2 add-ons still applies in Connect. You can reuse a lot of the tools that you've used in the past. If you're new to SaaS, I would recommend adding a new stage of testing to your arsenal of tests, which we call post-deployment verification tests. And this is a suite of tests that you can run immediately after your deployment, just to validate that your deployment has been successful. So with Who's Looking, that's actually quite a heavyweight suite of tests. We actually run real browser tests that go and interact with a real on-demand instance that's hooked up to a Who's Looking instance. And those tests actually log in as multiple users and validate that the iframe renders with the multiple viewers on a given issue. You don't necessarily have to go so far. You could start with a simple smoke test to make sure the application is deployed okay and is at least up and running. The idea here is to catch a failed deployment before it has any significant impact on your end users, so you can quickly either roll back or roll forwards, depending on the nature of the failure, with minimal impact on your end users. Another interesting area for testing with Connect is testing of features that are dependent on some kind of aspect of multi-tenancy. So an example of this in Who's Looking is, imagine you have 2 completely separate Jira instances, which both just happen to have an issue with key test 1. So they have an issue with the same key, but they're completely separate issues on separate instances. And then imagine you have 2 separate users, each accessing those separate instances and both looking at those separate issues. Well, you can imagine a naive implementation of Who's Looking that would conflate the 2 issues and believe that there's 2 viewers of one issue rather than 2 issues with 1 viewer each. So that would be really bad. That would be mixing up tenant data. That's definitely something we don't want to do. So that's the kind of thing that we want to test here. And as you can imagine, testing that with real Jira instances can get a bit heavyweight. But fortunately, what you can do is just mock out a small subset of REST APIs that are either required by your application or required by Connect to fool your add-on into believing that it's registered with a whole bunch of Jira instances. And I'd just like to introduce a very simple tool that I put together for Who's Looking. It's not very sophisticated, but it's a kind of potential starting point that you can use to do similar things. It's called AC mock tenants. And if you head over to ac-mock-tenants.herokuapp.com, you can see a bit about how it works. Essentially, it just provides a way of using templates to generate a large number of mocked out REST APIs, and you can then use that to fool your Connect add-on into thinking that there are many hundreds or thousands of on-demand instances there that it can register with and interact with. So if you have a look at the Who's Looking code and grep for that same URL, you'll see some examples of some tests that actually use this, and that might give you some ideas about how you can do similar things for your add-on. load testing. So this is another interesting area, because this is the one that will enable you to estimate the running cost of your add-on. And the approach I used is pretty simple. So I started off with a free tier instance of my application and load tested it to get a sense of how many requests it could handle. And from there, I kind of extrapolated, based on if I increased the usage, what paid tiers would I start to need to use? And from that, I could derive a rough cost of per user per month, essentially. And of course, while you're load testing your application, a good thing to do is to be able to get some insight into what's actually happening inside of it so that you can identify your bottlenecks and so on. And there's a variety of tools to help you do this. One that I used and found quite useful is New Relic. If you haven't come across it before, it's a tool that you can attach to a running application, even a production application, and it will give you information about the types of requests that it's processing and what's actually happening kind of at the method call level while it's processing those requests. And with that in place, when I first deployed Who's Looking, it was really only consumed by one Jira instance that we use internally at Atlassian. And that enabled me to get some idea of the request patterns. So, for example, I could see that about 95% of the requests being handled were the heartbeat requests, and about 4% only were the iframe requests. And the rest were requests for static assets, which I since moved off to a CDN. But by using those ratios, I could then put together a load test which would simulate requests with the same kind of balance of request types, but mimicking a very large number of requests, of on-demand instances and users. And so that gave me confidence that I could handle in the order of about 100 instances just on the free tier of the application. So that was enough for me to roll out to production to begin with. Now, the hardest bit I found about load testing my Connect add-on was generating requests that had the correct authentication to make them look like they were actually coming from real users. And in practice, that means that your requests need to have the appropriate JWT signatures and headers. So if you're not familiar with JWT, Peter is doing a really good talk on that tomorrow called Connect Security. So check that out. But in summary, if your requests don't have the appropriate headers, they will look like either invalid or anonymous requests to your application. And so therefore, they might not exercise the, the full code paths that you want to exercise during a load test. So I put together another pretty simple tool called AC Load Test, which pulls a range of things together. And it uses Gatling under the covers. I don't know if you've come across Gatling before, but it's a Scala-based HTTP load test generator. And it uses Gatling and an extension to Gatling to generate JWT headers. And so we can send those JWT-signed requests, a lot of them, over to the Connect add-on. And the signatures on those requests are such that they look like they're coming from users, from instances, mock instances provided by the AC mock tenants tool that I mentioned previously. So it kind of ties all these things together. And that's provided in the form of a Giterate template, which is a bit like a Maven archetype. You can kind of clone it and substitute some parameters in. So you should be able to use that as a starting point for load testing your add-on as well. So the output of all of that is some graphs that show you your kind of response time and throughput characteristics, so you can get a sense of your scalability characteristics. And if you're running something like New Relic at the same time, then you can get pretty good insight into where your bottlenecks are and what you need to improve in order to scale more. So a couple of tips that I can give you when you're doing this are, I like to run the client component of this load test on a fairly beefy EC2 instance, just to make sure that the bottleneck is on the server side. Obviously, when we're running this kind of test, we want to max out the server. And secondly, if you want to, you can temporarily bump up your load test instance to a paid tier of one of the components. So for example, if you think your bottleneck is probably the number of concurrent database connections that your application is making available, because you're on the free tier of your database service, which only gives you 10 concurrent connections, for the space of a load test, you can bump up to 50 concurrent connections, and use that to validate your hypothesis. And services like Heroku charge you by the second or by the minute. So if you only bump it up for the space of a load test, then that shouldn't cost you very much at all. Just remember to bump it back down afterwards. Cool. So at this stage, you'll have thought about hosting. You'll have thought about stateless request processing. And you'll have done a bit of load testing to get some sense of your running cost. One of the last things left to do is to kind of add some structure and maturity to your deployment process. So I'll just tell you how we do that in Who's Looking. So it starts off with a push to master in the Bitbucket repository, which triggers a build in Bamboo, which will do a bit of local building and testing. And if that goes well, we actually use Bamboo deployment plans to push that to Heroku, to a real Heroku instance. It's obviously not the production one, but it's a real web app. You can go to that URL and see it up and running. If that deployment goes well, we then trigger the post-deployment verification tests, which, like I say, are browser tests that go through a real on-demand instance that talk to this real Who's Looking instance. If those tests pass, then we can move to the next stage, which is effectively the same thing, but with a staging instance. So here, rather than pushing the application to Heroku, we use a Heroku feature called pipelines to promote the dev instance to staging, but otherwise it's the same pattern. And then, of course, as always, we run our PDV tests again. The only real difference here is that we also have a number of known real on-demand instances with real end users pointing to the staging version of Who's Looking. So if you've used ecosystem.atlassian.net, for example, that one is actually pointing to the staging instance of Who's Looking. So the benefit here is that we get some soak time with some real usage. And how long we leave it in soak kind of depends on the features that we've pushed. It can be hours or days, depending on the risk that we expect to be brought about by those changes. So finally, if that's gone well, then the last stage is, of course, to promote to production. And it's the same thing again. Big difference being that as soon as this thing goes live, then there are hundreds of real on-demand instances that see those changes immediately. Nonetheless, we still run our PDV tests so that if there is a problem, we can be the first to react and hopefully go and roll back or roll forwards before it causes any major impact on end users. And of course, all through the process, we get HipChat notifications to tell us what's happening. Now, even with all these precautions, things can still go wrong. So I've got a few more bits and pieces to tell you that can perhaps help mitigate some of the risks. So the first thing is make sure you can access your logs. Sounds obvious, but actually the default log story with, at least with Heroku, is not that great. Your log lines kind of disappear into the ether after a few thousand lines. But fortunately, there are a number of add-ons to help you with this, and that offer all sorts of features ranging from alerts on certain patterns of logs to enabling you to search your logs and that kind of thing. So have a look at the add-ons and find the right one for you. Feature flags is another very powerful thing that you can do. So the idea here is that you can wrap your new features in a conditional so that you can effectively enable or disable the feature through configuration without having to roll a full new version of your application. And another thing you can do is gather metrics and analytics from your application so you can see trends and identify patterns of behavior that suggest a problem, for example, with a dramatic change in cache hit ratio or that kind of thing. So again, there are lots of different tools and services that you can use for this. Personally, I use a library called Simon for in-memory metrics. And if I need to externalize metrics to be able to aggregate them across nodes or track them historically, then what I do is I just dump them to the Redis instance that I'm already using for other functionality in Who's Looking. But you can also use various other hosted services to aggregate your analytics. My last recommendation for you is to implement a health check. So a health check is really just a URL that your application exposes. And when you hit it, it will go and do some diagnostics on the application. And then what you can do is monitor that URL with an external service that will ping it on a regular basis and then alert you in whatever way you choose if it starts to identify a failure. So if you want, you can have a look at the health check for Who's Looking. It's just at who'slooking.herokuapp.com/healthcheck. If you go and hit that URL, you'll see that it returns a bunch of JSON with all of the metrics and configuration data and various kind of bits and pieces of information about the state of who's looking at that point in time. And of course, there's a little summary down here that just says if it's healthy or not. That says true, you probably can't see that. But if it fails, then obviously the various things monitoring it will fire. And one of the things we do is that we have it up on a wallboard, so that bit of green will go red if who's looking starts to misbehave. So in the background, this is accessing Redis, it's accessing Postgres, it's accessing all of the external services that who's looking uses. So if there are any problems with any of those or the connection with any of those, then that will be identified as a failed health check. So that's pretty much it. I'll just wrap up with a quick summary of my top tips for building a production-ready Connect add-on. So firstly, try and design for multi-tenancy and horizontal scalability from the onset. They aren't particularly complicated concepts, but they can be very difficult to retrofit into an existing application. Another good idea is to make sure that deployment is really easy from a developer's perspective, because the easier it is, the more frequently you'll do it, and the more you'll kind of reap the benefits, one of the biggest benefits of SaaS, which is being able to frequently push fixes and improvements to your customers without them having to do anything. Remember to check your third-party services. Remember to load test to estimate running costs. Don't forget your health check and your PDVs as well. And probably the most important tip, if you're new to SaaS, is to start with a simple add-on so that you can kind of incrementally discover all of these peripheral concerns around the core functionality of your add-on. And there are many ways you can start simple. The next talk by Tim about static add-ons is another really neat way to start with an extremely simple add-on and kind of progressively get into some of these concerns as you need to. So that's it. I'll just leave you with some stats from Who's Looking. The most important one is probably down here. So the current cost of running Who's Looking is about $0.005 per user per month. And if you want to grab these slides, they're available now at go.atlassian.com/prod-connect. Thank you very much.